allows me to talk about it one more way. All right, so here's our blood supply. So I'll put the picture up, but it's sort of the same as the book. Okay, so here's our blood supply. There's choline in the blood supply, right? Either free choline or we managed to get it repackaged into a VDL or an IDL or something like that. And then we're in capillary area, so it's pretty small. All right, so the choline hops out of the blood supply and attaches to the transport protein. This space is nanometers. So because this has a high Km or a low affinity for choline, it's going to grab some of the choline, but most of the choline is going to go on by to go to the next cell. That ensures that each individual cell doesn't hog all the choline, because this cell wants to hog all the choline. Not only does it have to repair its cell membranes, but it's got to make all this acetylcholine. Like, we make neurotransmitters at just a fantastically fast rate. We fire thousands and millions, really, of neurons every second, and we fire them using acetylcholine and dopamine and, serotonin, and we use endorphins. I mean, there are all kinds of neurotransmitters, right? So this is one we make a lot of. So if this transport protein had the ability to take all of the choline out of the bloodstream, it would. So then this blood moves on to the rest of the body. So it makes the acetylcholine, it releases it through those synaptic vesicles, it hangs out in the synapse. A certain number of receptor proteins on the receiving side, the dendritic side, grab the acetylcholine. But usually there's stuff left over. Or, after it's received the signal, that transport protein, or that receptor protein can then release it, right? So whether it's been released or there's extra, acetylcholine hangs out in the synapse. It gets broken back down into choline and acetate. So all over here, now we've got all this extra choline. And the acetylcholine needs as much choline as it can make to just keep making more and more and more. So this high affinity, low Km transport protein picks up all the rest. Does that make sense? Okay. So as far as I'm going to talk about the midterm setup after the short break. But this is a really good question I could ask you for like 5 to 10 points. Understanding how this works and what the difference between like high and low Km would be and why you would want multiple in certain areas. Okay, so that's why I focus on this one, because it's a great example of that that's not too complicated. I'll take my picture.